It didn't work. Hold on. Okay. This is Table Two's discussion of planar and non-planar graphs. These are our people who worked on the slide.
Who is Leonard Euler? Leonard Euler developed the formula V minus E plus F equals 2. Planar graphs help simplify complex data. These graphs show the relationship between vertices, edges, and faces, communicate graphical methods.
So a planar graph is a graph with a set of points connected by lines that can be drawn on a flat surface without any of the lines crossing over each other. And a non-planar graph is a graph that you cannot draw without any of the edges crossing. So basically, even if you move the dots around, you'll always end up with at least two edges crossing.
This was Precise's slide. Basically, the graph looks non-planar, but it actually is if you would move the dots and vertexes around. So when you're looking at a graph, you can't just assume automatically that it's non-planar.
Planar, but isn't set up to be that way. It's easy to do it online. So if you go to this link up here or type in untangling planar graphs, it should send you to this website. And this website is very helpful because you can move around the numbers easily and it tells you which numbers and which points are not yet planar based on what is red when you pick it up, right? You can add or adjust how many points you have based on the preset that they have here already listed, or you can customize your own number of points, right? So if we would start out with 6, doing it online on a screen is much easier than doing it on paper because you can move these about without having to worry about resetting and drawing your lines. Now the graph presents its planar when you move it about. So if we were to start with let's say 7 points, or let's go 8, right? It looks crazy and chaotic, obviously, the more numbers and points you allow. But taking it one angle at a time and practicing understanding which points you need to move and which ones you don't need to move is very helpful. So when you have something complicated, you just take it 1 point at a time until it becomes planar presenting, essentially.
So doing planar graphs on paper can be very different than doing them online because obviously I can't just move over the points. So before we even begin to untangling this, to make it look easier, what we're going to do is count the number of lines leaving the point, right? Just to get it organized. So we go through and we mark, okay, well, this is 1, 2, and 3, leaving F. So F has 3 marks. And then we just go down the line and do that. E has 1, 2, 3. D, 1, 2, 3, and 4. 1, 2, 3, and 4. And we just keep doing this for all of the points, and just so we have a knowledge of what our untangled graph is going to look like, right? Because they are different in between being not planar and planar presented, is they still have to be the same graph. So in both graphs, all of the points have to be connected to each other. So now that we have the number of lines leaving our points for each point, what we're going to do is we're just going to start to untangle. And we're just going to start all over. Rather from looking at this, we're going to just start all over. And the key point of starting all over is to leave 1 point out, just so we can begin to make it a lot less complicated and easier on ourselves. So since this graph has 6 points, we're going to start with 5 on this side. And we're just going to leave out F for now. So we have our new graph with 5 points, and we're going to label our lines again. So A, B, C in the same place, and we're just going to flip B and E around to make it easier. And now we just go through the points, right? So in this graph, A and B are connected, so we're going to connect that. B and C are connected, just a straight line. A and C, so we're going to go over B so they don't intersect. And then we have B and D connected, so we're just going to drop down to here. A and D are connected, and drop down. D and E are connected, and you just kind of go through the motions of seeing what graph is connected to what, right? So we have D and E, we have E and A, so we're just going to go all the way around, all the way over here. C is connected to D. No, it's not. So now that we have our points here, right, we have A over here connected to 3 right now. So we know it's connected to 4, but right now it's connected to 3 because we're missing a point. B right now is connected to 3. C right now is connected to 2. So we got C to B, C to A, C to F, which we don't have yet, and C to E. So we're just gonna drop down here. So now it's connected to 3. E is connected to 3 right now. So we know that E is done, right? So we're done with E here because our original E had 3 as well. D is connected to 3. So now we come back to F, right? So we're just gonna find an open point in the graph where none of the lines are connected, and we're gonna put the F vertex in there. Since this is our biggest area, we're just gonna put it right in the middle here. So now that we have F, we're gonna go see that D is connected to F. So boom, we're here. Now we have 4, D is done. We're gonna see that B is connected to F. And we're gonna see right here that boom, this becomes 4, B is done. F and C are connected right here, that's our 3. And I'm saying that we counted wrong, because A actually has 1, 2, 3, and 4 now. So our A is done as well. C now has 1, 2, 3, and 4. So now when we look, all of our points are connected and have the same number of connections where we started from. So A has 4, B has 4, C has 4, D has 4, and E and F have 3. So this is our planar graph drawn to have no lines connecting. And that is how you do it on paper.
This is Jada's slide. She could not make it, but once again, Leonard is the one who made the formula V minus E plus F equals 2, and planar graphs help simplify complex data. A planar graph is a graph that is a set of points connected by lines and can be drawn on a flat surface. And the lines will not, without any of the lines crossing each other.
Yeah, so to basically summarize what we've kind of already went over, a non-planar graph is a graph that you cannot draw without any of the edges crossing, no matter how hard you try. So even if you move the dots around, you will always end up with at least an edge crossing. And the graph on the bottom looks like non-planar because of the edges that cross, but if you move it around, it's actually a planar graph. So yeah.
Thank you for our
Thank you. That's
presentation.
it.